Today, we're jumping into a paper that completely changed the game in computer vision. It's called You Only Look Once, and it's built on a beautifully simple idea that finally made real-time object detection a practical reality. You know, it's wild when you stop and think about it. You look at a photo, and instantly you know what's in it, where things are, all of it. Our brains are incredible. But for the longest time, getting a computer to do that same simple thing was just a massive, massive headache. So the big goal here, the dream, was to create algorithms that could power the future. I'm talking about things like self-driving cars that have to see and react in a split second, or maybe even assistive devices that could describe the world to someone who can't see. But for any of that to work, you need one thing above all else: speed. And that was the problem. The old ways of doing things, well, they weren't built for speed. They were slow, they were clunky, and honestly, they were just way too complicated. Instead of seeing the whole picture at once, they were more like a search party, clumsily scanning thousands of tiny patches of an image one by one. To really get why YOLO was such a big deal, we gotta look at what came before it. Let's take a peek at the state-of-the-art system at the time, something called RCNN. Now, it was pretty accurate, for sure, but the way it worked was just this slow, grinding, multi-step process. Okay, so picture this. First, the system would generate about 2,000 different boxes on the image where an object might be. Then, for every single one of those 2,000 boxes, it would run a heavy-duty analysis to extract features. Then, another tool would try to classify each box. And then finally, it would try to clean up the mess. Each part was separate, which made the whole thing an absolute nightmare to optimize and just incredibly slow. And that really gets to the heart of the matter, you know? It's a completely different philosophy. The old way was all about taking tools that were built for a different job, image classification, and just forcing them to work for detection. The new idea? To build one thing from the ground up that does just one job. Look at the whole image and tell you what's in it, all in one go.
So what did all that old complexity get you? Well, one of the best systems back then, called fast RCNN, topped out at half a frame per second. Half. That's not even close to real-time video. Forget self-driving cars. At that speed, you'd be processing a frame from a crash that happened 10 seconds ago.
And this is where everything changes. Someone came along and asked a simple, almost elegant question that cut through all that complexity. What if instead of this exhaustive, piece-by-piece search, a computer could just, look, just once, like we do? That one question leads us straight to the core idea behind YOLO. And it wasn't just a minor tweak, it was a complete rethinking of the entire problem. The authors of the paper said it best. They reframed the whole thing as a single regression problem. Now that might sound technical, but all it really means is that instead of asking, is this a dog, 2,000 times, the network just predicts the box coordinates and what's in the box all at the same time. And from that simple idea, you get the legendary name, You Only Look Once, YOLO. Okay, so how on earth does that actually work in practice? How can one network just glance at a picture and pull all that information out? The magic is in its unified design. You throw out that clunky 4-part pipeline we talked about. Instead, YOLO is just one single beautiful neural network. You feed it the whole image, and out the other end comes everything you need, all the bounding boxes and all the class probabilities, in one single shot.
The secret sauce here is a super clever grid system. Just imagine laying a simple grid, kind of like a tic-tac-toe board, over the image. Each little square on that grid is then in charge of predicting any objects that fall right in its zone. It's so much smarter than guessing thousands of random boxes, because this way, the whole system sees the entire image at once. It has context.
So, what happened when they unleashed this new approach on the world? Well, the results were absolutely staggering, and this is important, the authors were refreshingly honest about the fact that it wasn't perfect. I mean, just look at these numbers. It's not even a fair fight. Remember that half a frame per second system? The standard YOLO model just blows it out of the water at 45 frames per second. That's more than fast enough for real-time video. And they even made a lightweight version that hit an insane 155 FPS. This wasn't just an improvement, it was a whole new world. But like I said, that incredible speed didn't come for free. The paper is really upfront about this. While YOLO is a speed demon, it's sometimes struggled with getting the location of objects perfectly right, especially when you have a bunch of small objects all crowded together. let's dig into the error analysis to really see what that means. The old system, FastRCNN, had a huge problem with what are called background errors. Because it was only looking at tiny little patches, it would often get confused and think a random patch of grass was an object. In fact, more than 13% of its detections were just plain wrong like that. Now, check out YOLO. Because it sees the whole image at once, it almost never makes that mistake. Its background error rate is down below 5%, nearly 3 times better. But you can see the trade-off right there. Its localization error is higher. So it was much better at knowing what was in the image, but just a little less precise about exactly where it was. So, what's the big takeaway from all this? What is the real, lasting legacy of this radically simple idea? Okay, this is one of my favorite parts of the paper, something truly unexpected. It turns out YOLO was amazing at generalizing. When the researchers trained it on a bunch of normal photos but then tested on something totally different, like artwork from Picasso, YOLO crushed the competition. Because it learns the big picture context, it wasn't easily fooled by a change in style. Ultimately, the legacy of YOLO is that it just tore up the old playbook. It proved that one unified, end-to-end system could be way faster and, in many ways, a lot smarter than a bunch of complicated parts stitched together. It basically made real-time object detection something that anyone with a decent GPU could actually do. And that leaves us with a really fascinating question, one that goes way beyond computer vision. YOLO proved that a massive leap in speed, even if it meant a small hit to precision, could unlock a whole new world of possibilities. It really makes you wonder, where else is the hunt for perfection actually holding us back from something that's fast, useful, and good enough to completely change the world?